Good morning, everybody. Today we are going to be going through a vertical panel saw. This one happens to be a Holzher. We're going to go through it from all the way from the floor all the way through to the scoring device. So with that being said, let's get started. Alright, good evening, everybody. I have had a couple of feedbacks from some of my colleagues out there, and they were just asking for a little bit more detail of the process. I know I did an overview in part one, but they were looking a bit more, some detail, how we're proceeding through the machine so that we can see the steps of procedure, so we're not jumping from one step to the next step to the next step, finding out I should have done step 5 over at step 3 and step 3 out of step 6, you know, that kind of thing right there. They just were looking for a little bit more detail. So I pulled the camera out real quick, put together this video so we can go through the processes, and then that way you can kind of get an idea of the steps of order that you're going to go through and tune the machine, you know, as far as what step you're going to do first, again, so you're not doing them out of sequence and finding out that you had to repeat work or that you did the work in the wrong position and a wasted time. Okay, so with that being said, we'll jump into this explanation. Okay, so I did this on a whiteboard on my desktop, so I apologize if some of the artwork looks a little hokey. Never claimed to be an artist, but with that being said, let's jump into some of the explanations and see if it clarifies some of the questions. Alright, so I'd like to jump in here for just a moment and kind of describe the process that we're going to be doing for bringing the machine back, or if you're setting it up from scratch, to get it to cut a repeatable square profile. So there's a few things that we have to do, and it has to be done in the correct order, or you will be running around in circles trying to fight the results that you're getting. Well, the first one we did in part 2 of this series, was that we went through and we squared the base up. So if you can forgive my crudeness of my drawing here, basically what we have is we have our floors across here, and we went through and we adjusted our different levelers up and down to allow the top rail to produce a straight horizontal rip. Now, part of that was that we went in and we canted the blade in the heel and toe to try to compensate for some of the error that was in the machine. And we did that as a temporary solution at this point. Once we do that, where we can create a perfectly straight rip that's within our tolerance, and the tolerances that I was taught was 0.1 millimeters per meter, or 4 thousandths of an inch per foot. 0.004 per foot. Okay, and where that starts to come into play is because now we're taking a book matched part and we're putting it together, all these numbers double up. So when you're going in and you're checking it, in the video I was both reacquainting myself to the machine as well as going through and tuning it. So I was going to half of these tolerances just because I needed to see what I can move and how much, things of that nature. Once that is achieved, what you're going to want to do is you're going to want to, at that point, go in and set the beam square. Prior to setting it square, at this point is where you're going to need to do the heel and the toe for the vertical cut. Now, this is where it starts to get tricky. It seems like we're running around in different circles, coming here, and we're jumping back and forth, and to some degree that statement would be correct. Now, what we want to do is, the reason that we're not worried about setting our heel and toe at this point is because if our beam is not square, when we do square the beam, it's going to change our heel and toe. Alright, now if for some reason you are unaware exactly what heel and toe means, that is the blade and the way that the blade is tracking. So if the blade is not perfectly parallel to the travel, that is called heel and toe. the nomenclature is directly related to the direction in which you're referring to the blade. So I could be standing on the left side of the blade and the blade be canted, let's say for instance this direction, and to me this would be toe in and this would be heel out. But if you were standing on this side of the blade, it would be the opposite relationship. So if you're talking with somebody and they're talking about heel and toe, it is important that you understand their frame of reference as they're discussing that term. Now, once we take the beam, and we've got the beam hanging, don't worry about square at this point, but we're going to go in and we are going to set the heel and toe for the vertical. That removes the influence that is applied to the travel. So if the blade is heeling one direction or the other, or if we got toe in, toe out, and it's traveling, we could have a perfectly square beam and cut an out of square panel. Or if the beam was out of square and the heel and the toe was the opposite, we could add influence to it and it would cut an out of square panel. Or it could make it, if it was really bad, it could bring it and make it cut a square panel. So you might say to yourself, why am I even concerned about this? Because if my heel and toe is capable of influencing the overall cut, just why worry about it? Where it starts to make differences is because heel and toe and the amount of heel and toe is directly proportional to the quantity of the cut. So if I was doing a short piece, like a drawer front for instance, that only cuts 6 inches, there is not enough material to truly influence the blade. If I was going through and I was splitting down the length of a 4-foot sheet, for instance, there is more than enough material there. If I was doing something that was a 1/4 inch thick, there's not enough material there. If I was doing something that was 1.5 inches thick, there's more than enough material there. So the heel and the toe needs to be correct before we worry about square. So we're going to go in, and so after we've done the horizontal, we're going to go in and we're going to set the heel and toe in the vertical. After that is set, then we set the square, and we use a 5-sided cut for doing the square. After this, I'll jump in and I'll explain briefly how the 5-sided cut works. Okay, the square that we have in here, once we do the square, at that point we will flip the saw back over to horizontal, and then we will do the heel and toe for the rip. So the first thing we do is we set the true of the machine, true level, true straight, all that. Then we set the heel and toe in the vertical. Then we set the square in the vertical. Then we set the heel and the toe in the rip. After all that is done, then we can come back in and we can start setting all of our scales. Now in the rips we've already set our scales, but we do have other scales that we can go in and set, like the vertical rip stations for the part length. So once that's done, everything else falls in and becomes very, very true from there. So it may seem at this point that in the first video that I was going over the rip over and over and over and over and over with very little results. That is because everything starts from there, and then from there, as we start to progress through it, things start to pick up pace. Okay, so once we got the horizontal squared away, we'll do our heel and the toe. We do that with double-sided melamine because it shows the greatest amount of error. That is a very tedious adjustment that we want to take our time and get that correct. Then from there we get our square into station number 1 or station 0, depending on how they're calling it, the one that is your primary ripping or crosscut station. We want to be very precise with it because that one is tuned using our rollers. If this is my beam, it's here. My beam falls. We got a roller, it's here on the top. We got a roller, it's here on the top. We got a guide pin that's down here at the bottom. We remove the influence of that guide pin. Just physically take it off the machine if it's applicable. If not, just make it where it's not influencing. Depending on what type of machine it is, there's a few different ways that we would do it. The Strebe is the easiest. It just has a round pin. It's about 22 millimeters round, or maybe it's 19 millimeters round. It takes a 22 millimeter wrench, something like that. 22's in there somewhere, and you just physically take that off, and that whole station at the bottom then is free to go wherever it wants. Then once we achieve that, we get this set so that the natural state of my beam is hanging on those bearings. At that point, we go back in, put our pin back in place, bring its influence back into it, test again to make sure that this beam is not being influenced. And once that's done, At that point, we go on to whatever remaining stations it is, and all we have to do is adjust the relationship of the pin on the machine itself. Now, the Strebig's, unless they've changed it, the way that the Strebig's are done is once this station is done, you're done, because the adjustment, the pins, the lower pins are all set and machined at the factory, so there really isn't any adjustment, subject to change. It has been a while since I've had to go in and set one up from scratch. Alright, so once we get that set, then we're going to flip our saw blade to the horizontal. We're going to set our horizontals, and again, we're going to be very, very tedious with that because we want to make sure that is correct. Alright, and let's see, from there, of course, our scales. When we're doing our scales, a lot of machines will have a short shelf that's across the middle. We'll have scales for the bottom, we'll have scales for the top. Sometimes they'll go off on both directions, and it's just a matter of going in and making cuts here, measuring the cut, make the adjustment. Go over here, measure the cut, make the adjustment, measure down here, repeat till done. Okay? Now, at some point, you're going to want to set the depth of your cut, and this is where it gets a little tricky. Okay, so I need to change my drawings, discuss a couple things with my 5-sided cut, and set us up for the depth of cut, and we'll be right back. Okay, for a 5-sided cut, it's very simple. It's a very easy process. Use it on sliding table saws, horizontal panel saws, vertical panel saws, anything that you want to have that's square. I suppose you probably could use it on a miter box if you wanted to get something that fine, but I don't do miter boxes, and I don't know why you'd want to get that close unless you were needing something very, very finite. But nonetheless, the process is very, very simple. You need a set of nice calipers. You know, they don't have to be a set of, you know, $300 Meditoyos, but you don't want to use a plastic set of some from the box stores. That just won't work. Okay, and then from there you also need a marker, and you'll need a sheet of material. It could be plywood, it could be MDF, it could be particle board. Doesn't matter. What you want is something that's thicker and stable. I would not want to use something like a 1/4 inch. I would, at minimum, a 1/2 inch. The thicker the better, the larger the better. So I have, as an example here, a 4 foot by 8 foot sheet, and what we are going to do is we are going to go up to one corner, and we're just going to put a pair of tick marks on it. And the tick marks serve a few functions. For starters, it is the first edge that we rip, and then also you notice I've got it stuck over in the corner, so this tells me my face, it tells me the first edge, and then when I get my strip off of my hand, it tells me the orientation of that strip after I do my process. So what we're going to do is the very first cut that we're going to do is we are going to go through and we're going to cut off this edge, and we're just going to make it, you know, just get rid of the factory edge. Once you do this the first time, every other testing beyond this point, we do not have to repeat this part. Okay, from here we're going to rotate the panel 90 degrees. And so do we rotate the panel 90 degrees to the right or to the left? And that answer is it depends on what process you're testing. So let's say, for instance, I was going to be doing a horizontal panel saw and my rip fence was on my left hand side. I'm going to rotate this around so that freshly cut edge goes against my reference surface. If I was doing a right hand side, I would rotate it clockwise. If I was doing a vertical saw, it would depend on which side of the beam that I was standing on. A lot of time when I do my vertical saw, I'm going to have the panel to the left of the beam because it's easier for me to manhandle it because the beam is to my right most of the time, not always, but most of the time. And then that way I don't have to work around the beam as much. I can just grab the panel and flip it. So rotate it right, rotate it left, doesn't matter, but the freshly cut edge goes to the reference surface. And then so you make a second cut, we would make that second cut. You're going to repeat that, rotate it again, you're going to make a third cut, you're going to repeat it, you're going to make a fourth cut, and this next cut is where it takes its name. You're going to make a fifth cut. Okay, hence where it takes its name. The last cut then sets you up for your next test if you need to, because it's already been ripped, there's no more factory edges. At that point, what you're going to do is you're going to take your ripping, get rid of this drawing here. At that point, what you're going to do is you're going to take your ripping. I've got a nice long strip, whatever this strip winds up being, and I'm looking at my face. You will see your two little tick marks that you used for marking your direction and the face and which was your first piece, stuff like that. Again, I use 2 tick marks. Sometimes I'll use 4. But what you want to do is just make sure you put some kind of chicken scratch on there so you can identify that corner and that surface and that particular part. At that point, what you're going to do is you're going to go in, you're going to snap it by hand in the middle, and then you're going to take the left side and the right side and you're going to compare them. And the thickness of this part of the ripping and the thickness of this part of the ripping will tell you how square it is. Okay? So when I'm going down, I'm looking at the face of this right now. So I'm looking down at the depth. I go down for the length of this, and what you will see is if I have a part that is truly being cut at 90 degrees, the 4 corners are 90 degrees, it will be parallel from this end to this end. If it's not parallel, then what you need to do is figure out which direction the beam is out or the fence is out. If it's a sliding table saw, it's going to be your traveling fence. But you need to figure out which direction that is, and I can tell you probably better than half the times I'm wrong, because I do this just long enough for me to sit and think about it, which way is it going to go, and then I overthink it, and I'm usually going the wrong direction. But if you do go the wrong direction, it doesn't matter. All right? So what you're going to do is you're going to see which direction your influence is, and then correct it, because then the next time you go to make a cut, you're either going to be more the wrong way or you're going to be heading the right way. Now, the next question that everybody asks me is how much is acceptable? So when I was taught this many years ago, I was taught that for machines that the following machine that processes, if it's a CNC machine like a rail and pod, or something that has a pin in it, something like that nature, then your tolerances is 0.001 or 1/1000th, excuse me, I had to get this straight in my head, 1/1000th of an inch per foot per cut. If you're just going to something like an edge bander, which is a little bit more forgiving than a CNC, it's 2/1000ths of an inch per foot, and that has to do with when you're doing a CNC, if the repeatability of your corners, if the part's out just a little bit, then you'll get shelves that rock and stuff like that, or you'll put it down on a floor and the box will rock or something like that. So that number, if we go back to my 4-foot panel that I had, now take in consideration that every time you cut it, it gets like an inch shorter, so I don't worry about that inches unless I start to get very small. But my first cut is where I take the name from. I scrap that value. So my second cut is 4 feet, 8 feet, 12 feet, 16 feet. So if I made my test and I snapped my part and I was measuring end to end, I would allow between 16 and 32 thousandths error in that part. I am fortunate that I carry a lot of some of the more precise tools, so the more finite we can set this up, the better off we are, and I pretty much will always tune to less than 16 thousandths. That will assure that this corner down here is square. Now, there is a test that people do that it drives me crazy as a person who does diagnostics all the time, is they'll take a corner and they will go in and they'll measure corner to corner and they'll say, hey, that part's square. They're correct in that it's square in relationship to that size. But when you start getting into variances in sizes and you're saying, oh, I allow corner to corner plus or minus a 32nd of an inch, that's fine as long as you know what your defining value was when you started. But if you're setting something up at, say, a 4-foot square panel, 4 foot by 4 foot, and you're allowing that error here, and then you shrink that value down to a 12-inch by 12-inch part, your error grows exponentially, because it is a wrong test. This thing that we just did here, this is the way it's done. Okay? Now, For quality control, if you're going to go out and you're really worried about whether or not you're producing square panels repeatedly, and you have somebody that needs to have a test on the floor, like on a production floor, then they sell those gauging machines that has a true 90 degrees that's measured into it, and you can either go in with feeler gauges and have go no-go gauges with feeler gauges, or the really nice ones will have a sliding dial indicator, can tell you. But if you go into this and you're saying, I measure corner to corner and it's square, I can go into this and I can cut myself a parallelogram, and obviously that is corner to corner not correct. But it is very possible that I could go into this and I could cut myself a trapezoid, and I can measure corner to corner, and that trapezoid could measure the same, and that part is nowhere near square. So this test is an invalid test, and I know I probably triggered some people there, but trust me, it creates a lot of problems when we start to get into some of the shops that have very tight tolerances. This test is not valid. Okay, so that's how you do a 5-sided cut. That's how you test it. It is a tedious setting, but once you get the hang of it, it's not too bad. The worst part is taking the panel and flipping the panel, because it gets kind of boring, to be honest with you. And after you do the number of machines, it's really boring. Okay, now going back to the depth of cut, when you're setting your depth of cut. So we went in to our machine, we set the horizontal, we set the square, we set our heel and toe, we set our heel and toe in the horizontal. Then what we want to do is we want to make sure that the depth of cut is correct, because depending on what product you're cutting, how far the gullets of your saw blade protrude past the back of your part, or just as importantly, how far they protrude past the front. If you're doing like a Stribics, use the back of the blade as a scoring device, so they don't truly have a scoring device. It's a neat process, but they don't use it. If your depth varies as you're traveling up the part, it will cause you problems. Okay, now so what you have, if you can imagine, this is my back support, this is my panel, here's my little shelf that's at the bottom, my part sits here. I have the frame that's on the top, and then my beam that comes down. I know this is a really bad drawing, but if you can imagine that, down here at the bottom, all the machines will have a roller of some sort down there that traces the bottom of your frame as it goes across, which when you're going through and you're doing your cleanings and everything, it's one of those surfaces that we always tell you to keep clean, because if you have dust that's up here, you have dust that's down here, as it's going through, it will shake that beam, and that vibration you put in the beam will then transfer to your blade, cause your blade to vibrate, and cause you to chip. So down here at the bottom of this, then what you will do is you will adjust this bottom either in or out to influence the bottom of this beam so it hangs at the same gap that it has at the top. The way that you check that, you lay yourself a panel onto your back of your machine, and then the way I do it anyway is put a dial indicator on your saw carriage and just run it up and run it down slowly by hand, and watch and see what your error is, and then correct your bottom. Once you get that to where it's, again, our 0.1 millimeters, 0.2, something like that, in our vertical, then we're good. If this machine was setting up to do V-notches, then it's certainly got to be less than 0.1 at the very most, or else you'll never cut a successful V-groove, because it will cut a different V-groove at the top than it will at the bottom. You go to try to put your parts together, it will drive you back crap crazy, because you won't know where it's at, and it's down here. So it's a very easy adjustment to have wrong. Okay, now once you do that, then you can go in and set your depth of cut. And again, what you want, depending on what your saw blade is, typically you want where your carbide of your tooling is right where it's just starting to punch through the back of the blade, but you don't want the gullet to come completely through. And if you have any variance in there, that's very difficult to control. Okay, so that's how you set your depth of cut and the process before you get there. All right, so the last thing you're going to set in this primarily the last thing. There may be a couple of minor tweaking things that need to be done, is your scoring device. And there's several different styles, and I can't honestly remember them all. At one point, it seemed like some of the old Striebigs actually had a real saw blade, a little scoring blade in there, had a little twisted figure 8 round belt was inside. It was a very neat but complicated system. It was neat the way it worked, but it was complicated to maintain, especially if heel and toes and stuff were off. The Holzhers, and I'm sure a couple other people have a physical scribing device that jumps in and actually scratches the surface. And in the example that I have here in my videos, in part, we might get into it in 3. We'll certainly be doing it in 4. What you will have is that you will have a rubber wheel, and this wheel is about 50 millimeters or so, might be 40 millimeters around, and then behind that is a carbide insert. Nothing special, just a square carbide insert. The depth of the scoring is governed by the projection of that carbide past the face of your wheel, and all you want to do is just scratch your material. So if you are doing melamines, you know, if you've got a 0.1, 0.2 millimeter through the face of that, that's deep enough. If you're doing veneers, then you need to make sure that you're cutting at least deep enough through the veneer that you're not ripping the veneer out. So you kind of have to feel that one out as you're going through it. Okay, and then the way that those adjustments for this works is that have 2. I have one on the right, one on the left, and they have a, if I draw my wheel here, and I'm viewing from the end, I got the second wheel, here's my other diamond. This is obviously not to scale, and I'm viewing, my sheet stock is behind me, and I'm looking forward. What I have is a set screw that's in between these two. It's actually kind of in this area. And what we do is we either push or pull these wheels open or closed to get it to shift left and right. So you kind of do it like an inchworm. If this side needs to cut more, then you crank it out. You leave this side locked. If this side needs to be influenced, then you lock this one down and you adjust this side. And you just kind of inchworm your way back and forth. What you don't want to do is loosen both of them up, because if you loosen both of them up, you lose your reference. Okay, so it's done one at a time. Then the actual depth of it, or excuse me, the width of it, what you will do is that you will take, you've seen how we were doing our heel and toe, where we do a plunge cut and we run up so far. It's the same principle. So when I would make my cut, I would be dropping down from the top, and I would go down to where I know that the blade is completely into the board, that it's dampened in the board. And once that happens, you'll see where your blade stops, and then you'll see these little scratch marks that run ahead of it. And because you're using your carbide knives, the outside of it is the 90-degree part of your knife, and it will cut a very clear and defined line in there. And then you take yourself a little bit of a marker and you go in there and you kind of backfill that line, and it will show up like night and day. Okay, and at that point, what I do in there is I got a magnifying glass, because let's face it, I'm getting older, my eyes aren't as great as they used to be, so I get a magnifying glass out, and it's just wonderful. You can see everything. And at that point, you just make your adjustment to the left or to the right. The way that Striebig, unless they've changed it, and I don't know why they would, but you know, sometimes they change stuff and they don't bother checking with me, because you know, I'm not that important to them. The way that Striebig does is, we know that we have a parting tool that comes out, a little splitter comes out and follows the blade. So if this is my hood and my saw blade is out here, what we do is we take this face of this, if you take a look at it, you'll see that the face of that shoe is flat, and we will adjust your shoe either forward or backwards to give more exposure to the tip of your blade. So the downside to this is every time you change your blade, you have to change your scoring. Unless it's just not really important to you, then you just kind of run it where it's at. But the amount of the distance that this face of this and the blade, the projection of your blade beyond it, is the depth of your score. All right, and the only way you can check it is actually do a scoring cut, and you put a caliper into it, depth side depth test of a caliper, and you measure the groove. So the way it works is, if this was my part, then I start at the bottom and I make a plunge cut where that splitting device touches, and then I drag that part backwards, and because the saw blade is now projecting past that shoe, it allows that blade to cut. And then once it gets up to the top, then you finish your plunge cut, and then you come back down. And then we went through and we were doing our heels in the toe, and we were very, very precise with that. But if we had any error in this and we needed this to be correct, we go back to our heel and the toe, and we make our correction in the heel and the toe to line up our scoring. So the scoring, regardless whose machine it is always done last. Okay, after all your measurements done, after your squaring's done, if your alignment's done, everything else is done, scoring is the last item. Okay, so that's kind of the processes that we go through all these machines. So in my videos, I've got, we did that overview for part 1. Part 2 was the horizontal. Part 3 will probably be this video. Part 4 is going to be the physically squaring of the vertical stations. And I might get into some of the heel and toe. I'm not sure, that video is still being edited. And then 5 is going to be the scoring, because I do have a Streebig that's coming up. And of course I have the Holzhers. I don't have any of the Elcons. There's a few of them around in my area, but I just don't have any on the books yet to go in and service. Alright, so I hope that you find this beneficial. And as always, if you have any questions, feel free to leave a message down at the bottom. Like, subscribe, share, comment. And as always, be safe out there, wear your PPE. Let's all go home safe, and let's go make a million.